Hello everyone, hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT/IC Department. Welcome to the video tutorial series of the Data Communication and the Computer Network. In this session, we will discuss an error correction technique and its one type, the Hamming code in brief. So first of all, we will see the outline of the today's session. We have briefly discussed about how we can detect if error is occurred or not, right? So we have seen the error detection technique in our previous sessions. From now onwards, we will see the error correction techniques. In that, we will see if the error is detected, so how we can correct the error and how we can get our original data from the erroneous data. So we will see that in brief, right? So in that session we will see the forward error correction technique, right? So what do you mean by the error correction, right? So in that as we discussed, if we found any error, we are trying to get our original data which is sent by the sender side, right? So to getting that the data which is sent by the sender side, we are applying so many techniques on that, right? If the error is happened, so that technique is called the error correction techniques. In that, its type is forward error correction. So it is an error correction technique to detect and correct a limited number of the error in transmitted data without the need of the retransmission. With the help of the error correction technique, you don't need to retransmit the data if error is happened. You can simply correct that error by applying this technique, right? So by the error correction technique, you don't need to retransmit the data if error is happened, but it is correcting the error in the limited number of the error in the transmitted data, right? So this is a major drawback about that. After that, in this method, the sender sends the redundant error correcting code along with the data frame, right? So in this technique, we are sending an redundant error correcting code. With the help of that, we are getting our original data if error is happened or not, right? So with in the error correction technique, we are sending some error correcting code, the redundant error correcting code along with that data frame, our original data, right? So the receiver performs the necessary checks based on the additional redundant bit, and it is guessing that if error is happened or not, and if the error is there, so how we can recover the error, right? So how we can get our original data from that. So with the help of that redundant error correcting code, the receiver performs the necessary check about that, and it will checking that if error is there or not, and if the error is there, so it is applying the error correction methods and get the original data which is sent by the sender, right? After that, if it finds that the data is free from the error, then it removes the redundant bit and accepts the data. If it finds that the data is free from the error, then it removes the redundant bit and accepts the data. And if there is an error, it will apply some techniques and get the original data from that, right? So that's how the forward error correction technique is working. Let's see the Hamming code first, which is the type of the forward error correcting detecting technique, right? So what is Hamming code according to you? It is a forward error detecting code that uses the redundant bit to correct a single bit error, right? So Hamming code is used for correcting a single bit error, and it is an error detecting code, right? So Hamming code can be applied to the data of any length and is used relationship between the data and the redundant bit, right? So that this technique, the Hamming code, can be applied to the data of any length, right? And it uses the relationship between the data and the redundant bit, which is added with the data frame, right? So let's see the relationship between the data and the redundant bit, which is satisfied the following equation. The equation is 2 raised to r, which have to equal to or greater than m plus r plus 1, where m is the data bit and r is the redundancy bit. So the 2 raised to the redundant bit is have to greater than or equal to the data bit plus redundant bits plus 1, right? So let's see by some example. If our data bits are having the only 1, 2, 3, 4, 5, 6 and 7 and so on. So let's see its relationship. So our number of the data bit is 1, so we can apply that redundant bit as a 2, right? So 1 plus 2 plus 1 is 3, right? It is greater than or equal to that. So 2 raised to 2 is 4, so 4 is greater than or equal to m plus r plus 1. So 1 plus 2 is equal to 3 plus 1 is equal to 4, and 2 raised to 2 is also 4, so we are satisfying this equation. After that, the number of data bits is 2, and we can select the redundant bit as a 3. So 2 plus 3 is equal to 5, 5 plus 1 is equal to 6. So 2 raised to 3 is equal to 8 there, right? So we can get that it is satisfying this equation. Likewise, the number of data bits are 3 and the redundant bit is 3. So 3 plus 3 is equal to 6, right? So 6 plus 1 is 7. So 2 raised to 3 is equal to 8. So it is satisfying that equation, right? So we can have the redundant bit as a 3 only, right? Likewise, if the number of the bit is 4, so we can set the redundant bit as a 3, right? So 4 plus 3 is equal to 7 plus 1 is equal to 8 is equal to the 2 raised to 3, 8. 8 is equal to 8, so it is satisfying the condition. But what if the number of the data bit is 5? So we can select the redundant bit as a 4, right? So 5 plus 4 is equal to 9 plus 1 is equal to 10. So 2 raised to 4 is equal to 16. So it is satisfying the condition. So that's why we are selecting the redundant number of the redundant bit with respect to the number of the data bit, which have to follow this equation. 2 raised to r is greater than or equal to m plus r plus 1, where r is equal to redundant bits and m is equal to data bits, right? So this is the relationship between the data and the redundant bit, right? So after that, let's see by one example. In that, so 7-bit data requires the 4 redundant bit, as we have shown, right? That can be the added between the data units, right? So this, we have the 7 bit of the data required, and we are having the 4 redundant bit, right? So 7 plus 4 is equal to 11. 11 plus 1 is equal to 12. It is less than or equal to 2 raised to 4 is equal to 16 is greater than the 12, right? So this is satisfying the condition. So we can set that the redundant bit as a 4, where we have the 7 bit as a data, right? So let's put the redundant bit in between the data bit, right? So this is the positioning of the redundant bit, where we are putting the redundant bit as the position 2 raised to the form at the first position, second position, fourth position, 8th position, 16th position, and so on. We are putting the redundant bit at that positions only. So this is the position of the redundant bit. At the position 1, we have put it the R1 redundant bit. At the position 2, we have put it R2 redundant bit. After that, at the third position, the data bit is there. At the fourth position, 2 raised to 2 is equal to 4. So we have put it the R4 redundant bit at the fourth position. After that, at the 5, 6 and 7 position, we have put it the data bits there. After that, in the 8th position, we have put it the R8 redundant bit. After that, from 9 to 15, we are putting the data bits there, right? And so on. So that's how we are setting the redundant bit in between the data bit, right? The redundant bits are placed in the position 2, 1, 2, 4, 8 and so on, as we have discussed, right? The redundant bit position in the 11-bit sequence that are the power of 2, right? So in the Hamming code, each redundant bit is a VRC bit for one combination of the data bit, right? R1 is the VRC bit of the one combination of the data bit. R2 is the VRC bit of the another combination of the data bit. R4 is another combination of the VRC data bits, and so on, right? So that redundant bit are the VRC bit of the combination of the data bits, right? So let's see how it's working. So the combination used to calculate each of the 4 R value for the 7-bit data sequence as the follow, right? So the redundant bit R1, it is the VRC of the bit 1, 3, 5, 7, 9 and 11, right? So if we are having an even parity checking, so we are seeing the bits which is stored at the position 1, 3, 5, 7, 9 and 11. If it is having an even number of the data bits, so we are putting the R1 as a 0, and if the bits are 0, then we can put if the bit is having the odd number of the 1, then we can put an R1 as a 1, right? If we are following the even parity check in this system. After that, at the R2 data bit, we are selecting the data bits position at the 2, 3, 6, 7, 10 and 11 and applying the parity checking there, right? If it is satisfying the parity system, then we can put the 0 and 1 respectively, right? After that, at the R4 position, we are selecting the bit position 4, 5, 6 and 7, right? Likewise, with the respect of that, we are selecting that redundant bit. After that, at the R8 position, we are selecting 8, 9, 10 and 11 to find out the R8 position, right? For the 8 position redundant bit, we are selecting the bit 8, 9, 10 and 11 to find out the VRC of that and selecting the redundant bit value, right? So that's how we are selecting the value. The redundancy bit calculation, R1 will take care of this bits and so on for the R2, R3, R4 and so on, right? So as we have discussed about how we are selecting the redundant bit R1, R2, R4 and R8, right? So this is the sequence of that. The R1 at the first position, R2 at the second position, at the third position we are putting the data bits, at the fourth position we are putting the redundant bit 4, 5, 6, 7 position we are putting the data bits. After that, at the 8th position we are putting the redundant bit R8. After that, 9, 10 and 11 position we are putting the data bits there. That's how we are arranging the redundant bit in between the data bits. And how we are selecting that redundant bit R1, R2 and R8 with respect to the data bits, right, and its position, as we have seen in that, right? So let's see by one example, right? For an example, we are having an data 1001101, right? So we are selecting that data bits, right? So we are putting that data bits in between, right? So at the position 1, 2, 4 and 8 we are putting an redundant bit. So except that position we are putting the data bits, right? At the position 3, 5, 6, 7, 9, 10 and 11 we can put our data bits, right? So at the 11th position we are putting the first bit of that 1. After that, in the 10 and 9 position we are putting the 2 zeros as that, and likewise we are putting the data bits in the sequence, right? At the position 11, 10, 9, 7, 6, 5 and 3 we are putting the data bits there. After that, we are putting the redundant bit there at the first position, second position, fourth position and the 8th position. We are putting the redundant bit in between the data bits, right? And with the help of that we are calculating the redundant bit there. Let's calculate the even parities, right? So we are selecting the even parity kind of thing to calculate our Hamming code. So let's begin with that. So for selecting the first bit R1, how we can calculate that, how we can guess that what is the value of that redundant bit R1. So we are selecting the even parity checking for that. So for selecting the R1, we are taking the data bits at the position first, second, third, 5, 7 and 9 and 11, right? So we are taking the data bits which is stored at the position 3, 5, 7, 9 and 11. So what are the value which is stored at the position 11, 9, 7, 5 and 3? That data bits are 1, 0, 1, 0 and 1. So that are having the 3 ones in that. so which is having the odd number of ones. So to make an even parity, we are selecting that data bit R1 as a 1, so we can have the even number of ones in that sequence. So we are selecting the data bit R1 as a 1 there, right? So that's how we are selecting the data bit R1 as a 1, right? After that, what if that's how we are selecting the data bit R1, the redundant bit R1. After that, let's select the second redundant bit R2. So how you are selecting the data bit? So for selecting the data bit R2, we are selecting the bit which is stored at the position 3, 6, 7, 10 and 11, right? So in that we are selecting the data bits. So what are the data bits which is stored at the position 3, 6, 7, 10 and 11? That bits are 1, 1, 1, 0 and 1, right? So which is having the 4 ones in that sequence. So that is the already even number there. So we don't need to put an 1 at the redundant bit, right? So we are simply putting the 0 at the redundant bit which is stored at the R2 position. So we are changing the value of the R2 with 0 there, right? So after that, that's how we are selecting the R2 and R1. After that, let's select the third bit position R4, the redundant bit. So while selecting the bit position R4, how we can select that? So for that, we are selecting the bit which is stored at the position 5, 6 and 7. What are the value which is stored at that position at the 5, 6 and 7? That data bits are 0, 1, 1, which is already having the even number of the ones in that sequence, right? So we are simply putting the 0 at that redundant bit R4. So we are replacing the R4 with the 0 there, right? So that's how we are putting the value at the redundant bit R4. So R1 is the 1, R2 is 0 and R4 is also 0, right? Let's select the last redundant bit R8. How you are selecting the redundant bit R8? For that, we are selecting the data point at the data position at the position of the 9, 10 and 11, right? So what are the value which is stored at that position? That are the 1, 0, 0, right? So 0, 1, 1 is the value which is stored at the position 9, 10 and 11 respectively. So there are the only one in that, so it is having the odd number of the 1. So to make that 1 in the even number, we are simply putting the 1 at the redundant bit R8, so we can have the even parity there, right? So that's how we are changing the bit sequence R8 with the 1 only, right? So that's how we are selecting the redundant bit R1, R2, R4 and R8, right? So to select that redundant bit R1, R2, R4 and R8, we are having the different kind of the bit combination and we are finding the VRC of that, right? So that's how we are finding the redundant bit in the timing code, right? So this is the calculation about the even parity and how we are selecting the redundant bit. We are selecting R1 as a 1, R2 as a 0, R4 as a 0 and R8 is a 1 there, right? So that's how we are selecting the redundant bit in that. After that, let's see if the single bit error is happen, right? So how we can detect that? So if the sender is sending the data 1001111000101, which is finding out, we have find out the value of the R1, R2, R4 and R8, right? And the original data bit is in that, right? So if we are sending the data from sender side to receiver side, and if any error is happen and somehow the any bit is changed due to the any kind of the code position, any kind of the codes, so how we can detect and correct that code? So for an example, at the 7th position, the bit value is changed from 1 to 0 and the error is happened there, right? Sender is sending that bit sequence and receiver is receiving that bit sequence. So we have the difference between at the 7th position. At the sender side, the sender has sent the 1 at the 7th position, and at the receiver end, the receiver is receiving the 0 at the 7th position. The other bit sequence is remain as it is as the sender has sent it. So how we can detect and correct that erroneous bit with the help of this Hamming code? So let's see by an example. So this is the bit which is erroneous. We have changed we have get the 0 bit instead of the 1 at the 7th position. So how you can detect that? So the error detection using the Hamming code we will learn. So at the bit position R1. So at the bit position R1, what is that? It is the 1 there, right? So for that we are selecting the bit 1, 3, 5, 7, 9 and 11, right? So what is the code there? At the 11th position there is the 1 there, at the 9th position there is the 0 there, at the 7th position there is the 0 there, at the 3rd position there is the 1 there, and at the 1st position there is the 1 there, right? So they are having the even number there, so the R1 is 1 only, right? So after that the R2 is the bit sequence. We are selecting the data bits as the 2, 3, 6, 7, 10 and 11, and we are checking that redundant bit is same or not. So we are getting the 1 at the redundant bit 1, right? At the 4th position the redundant bit is we are selecting the data bits at the position 4, 5, 6 and 7, and we are getting that the redundant bit as a 1, right? And likewise at the R8 position we are getting the value of the bit sequence 8, 9, 10 and 11, and we are having the if we are checking that the even parity, we are getting the 0 at the R8 position, right? So if we are putting that value in the sequence, so what is that sequence? 0, 1, 1, 1, right? So that is the 0, 1, 1. What is its binary number? It is 7, right? So that's how we are knowing that at the 7th position the bit is changed. It is erroneous, right? So that's how we have detected the value which is at the 7th position the error is happened. So in that we are receiving the 0, right? So what is the possibility of the actual value? In the binary code the value is 0 or 1. So if we are getting the 0 at the 7th position and it is erroneous, so it is only the possibility is the sender has sent the 1 at the 7th position, right? So at the 7th bit the error bit is complemented the bit at the 7th position, and we are getting the value at the 1 at the 7th position. So that's how we are detecting and correcting the value at the 7th position, right? So that's how we are detecting and correcting the error in the Hamming code with the use of the Hamming code. In the forward error correction method we are following this method, right? So that's how we are selecting the erroneous value. What is the Hamming distance there? Between the two words of the same size, the number of the difference between the corresponding bit. The Hamming distance between the two words x and y can be shown as the d of x and y, the distance between x and y. The Hamming distance can easily be found if we apply the XOR operation on the two words and count the number of ones in the result, right? Note that the Hamming distance is the value greater than the 0, right? So let's see by one example. So this is the value, right? The Hamming distance between the two words. So the Hamming distance between that value, the 000 and 011 is 2, right? So how we are getting that Hamming distance? We are simply putting the XOR gate between that two values. So 000 XOR 011 is 011. That is the two ones there, right? So the Hamming distance between the two values is 2. Let's take another example. What is the Hamming distance between the value? Distance between 10101 and 4 times 10. That is if we are putting the XOR, we are performing the XOR operation between the two values. What is the output there? 10101 XOR 11110. Our result is 0 1 0 1 1, right? So that there are the three ones that in that result, right? So the Hamming distance between that two words is 3 there, right? So that's how we are finding out the Hamming distance, right? So that's how we are finding the Hamming distance. We are simply applying the XOR operation between the two words, and we are finding out what is the value of the number of ones in that. The number of ones in that result is the Hamming distance there, right? So after getting that, what is the Hamming distance? What do you mean by the minimum Hamming distance? Also, the concept of the Hamming distance point is dealing with the error detection and the correction code. The measurement that is used for the designing a code is minimum Hamming distance. The minimum Hamming distance is the smallest Hamming distance between all the possible pair of the set of the word, right? So the minimum Hamming distance is the smallest Hamming distance between all of the possible pair of the set of the word, right? So that's all about today's session. We have discussed about what is the error correction, why we are doing the error correction techniques. In that after that we have seen the forward error correction technique, and we have seen its type, the Hamming code. So that's all about today's session. Thank you for the watching.